Okay, so some more examples dealing with so we're the reverse direction. All right, here's a graph. Let's come up with the equation. And so for this example, I noticed that I have a vertex, and so that's great to start, right, in vertex form. So like right there, so that is what, -3, -4. And remember, so, vertex form is y equals some coefficient a, x minus h squared plus k. And so I know that at least my h and k, since the vertex is -3, -4, I know that, those are my corresponding h and k values. So then I know that it's x minus -3, so it's x plus 3. So y equals a, x plus 3 squared, and then minus 4. Okay, but what we don't know yet is that coefficient a. How wide is this parabola opening? And so, like I am given this extra point here, which is what, -6, 2. So I also know that -6, 2 is on my parabola. So that means I can substitute that into my equation and solve for that coefficient of a. So I can solve, -6, 2 is my coefficient. Oops, well, I thought I was choosing purple. 2 equals a, and then our x value of -6 plus 3 squared minus 4. And so -6 plus 3 is -3. -3 squared is 9. So I have 9a. So 2 equals 9a minus 4. So I can add the 4 over, so I get 6 is equal to 9a. Divide by 9, so I get 2/3 equals a. So I know that my parabola is opening 2/3 as fast, right? So it's a little bit wider. And so I could then go back and say, okay, my equation is y equals 2/3 x plus 3 squared minus 4. And there's my equation. So just looking for that particular vertex. Okay. Now you could do the same thing here, even if your parabola opens sideways, right? We know our vertex is here, which is 3, 2. So even though this is opening sideways, when you write an ordered pair, it's still x, y, right? It's still 3, 2. It's still over 3, right? Over 3 and still up 2. So like that doesn't change, but the way we put them into the equation is different, right? Because like any parabola opening left and right is x equals some coefficient a, and then it'd be y minus k squared plus h. Where again, the vertex, because it's x, y, our vertex is still h, k. Just remember the h, which is the x component, modifies the x variable. And then the k, which is the y component, there's our purple, right? Y component, there's our k, modifies the y coordinate. So if I know that my x is 3 and my y is 2, putting them in the appropriate spot, x equals a, y minus k, so the y value is 2, so minus 2 squared plus 3. Okay, now if you look closely, there's another point over here. This point is -6, -4. The x value is -6, the y value is -4. So now I'm going to put -6 in for the x. Just change it up. I don't know, like to make things colorful. -6. Oh, but the smartboard says no, keep it purple. A, and then -4 minus 2 squared plus 3. So I can subtract the 3 over. That becomes -9 equals a times -4 minus 2 is -6 squared is 36. So I have 36a divided by 36. So I get -1/4 equals a. And again, the fact, first of all, that it's negative tells me it's opening in a negative direction, which is to the left when you're in the xy direction. And then 1/4 is fast. So it's going to be 4 times wider because it's increasing a fourth as fast as a normal parabola. And so then if I put my equation up here, let's go maybe nice red, hopefully. X equals -1/4. Oh, there it is, y minus 2 squared plus 3. Okay, excellent. Okay, and then another one here. So this, this one has a vertex at -1, up 7. And I notice it also contains the point here, 0, 4. So, again, thinking vertex form, y equals a, x minus h squared plus k. So that means y equals a, and then it would be x minus a -1, so x plus 1, because the -1 is an x component, so it's modifying the x, squared plus 7. And now I can put in 0, 4, 0 for the x, 4 for the y. So 4 equals a. So 0 plus 1 squared plus 7. So subtract the 7. 4 minus 7 is -3 equals a times 1, or just a. So that's nice. And then notice, again, notice that the value is negative, which corresponds to opening down. So then we say our equation is y equals -3 x plus 1 squared plus 7. Now, the other thing I was going to say about this 3 here means that it's increasing 3 times as quickly. So if you remember the last video, I mentioned, when you go over 1, 1 squared is 1. But 1 squared is 1, but then when you multiply by 3, it's stretching it all the way down to there. So then I can say, okay, well, now if I go over 2, 2 squared is 4. 1, 2, 3, 4. But then if I triple that, that's actually 12. So I have to come all the way down here to 12 units there to get the next point. So, and then I'd say, okay, well, 3 squared is 9. All right, so 9 doesn't take us nearly as far, but if I triple 9 to get to 27, that's, so that's how far down I'd have to go. So again, this coefficient here just really affects the rate of increase. But every parabola, if it's in quote unquote the standard, 1, it goes over 1, 1, because 1 squared is 1. It goes over 2, 4, because 2 squared is 4. It goes over 3, 9, because 3 squared is 9. So that's just kind of like the pattern. Okay, so then our last example is kind of like a bonus example, because there are 2 problems here. It says, find 2 equations. And I know I asked this so many times on quizzes. So you don't have a picture. All you know is a vertex and a point. So, create a picture maybe, right? Help yourself see this problem a little better. There's your y-axis. There's your x-axis. And it says 2, 3 is the vertex. So over 2, down 3. 2, -3, and it contains the point 1, 5. So maybe I'll make that one in like a blue color or something. 1, 5. Okay. So here's what it doesn't tell us. It doesn't tell us the direction. It doesn't tell us the orientation. You could have a vertex here and a point up there. And so one way this parabola might look is something like this. Very skinny, opening up like that. Right? But it could also be something that is a little bit wider and opening towards, oops, I thought I picked a new color. Just didn't register. There it is. Something is opening right towards the left. So we've got to consider both examples. So let's do the one that is opening up. So I'll go back to this color. So that would be y equals some coefficient a, x minus h squared plus k. So then our h value is 2, and our k value is -3. So y equals a. So it's x minus 2 squared minus 3. And now we can put in the point 1, 5. So then 5 equals a. 1 minus 2 squared minus 3. So we add the 3 over, which is 8. 8 equals a times basically 1, right? So then, so a is 8. So then we get y equals 8 times x minus 2 squared minus 3. And I was just looking at this graph, to go from 2 to 1, so you've gone over 1 unit, and 1 squared is 1, but notice that this is up 8, because from -3 to 5, that's an 8, so like a 1 to 8 ratio, which is exactly what was predicted by that 8 there. 2 squared is 4, so going over 2 and then 4 which is 2 squared is 4, but then I have to take it times 8. I had to go up 32 just to get to the next point. Again, making this parabola, at least in the orientation opening up, extremely narrow. Okay, then what if it's opening to the left? So then I could say, okay, well, things that open left and right start with x equals. So x equals a y minus k squared plus h. And so then I know x equals a y, and then remember -3 is the y value, so it's y plus 3 squared plus 2. And now put in your 1 comma 5, but remember 1's the x value, 5 is the y value, so 5 plus 3 squared plus 2. Subtract the 2, so 1 minus 2 is -1, equals 5 plus 3 is 8, 8 squared is 64, so 64a, divide out the a, sorry, the 64, so I get -1/64 is equal to a. So very wide compared to our, our other parabola. And so then we complete it by saying x equals -1/64 times, where is it at? Oh, there it is, y plus 3 squared plus 2. Okay, so again, just some hopefully things that look familiar, and even if you didn't remember like every single detail, it should look familiar from some pieces, and that's kind of the whole point or the process here, is that we start we start kind of catching up and remembering things and putting things together from at one point that we had learned them and we're experts on. So okay, so again, let me know if you have any questions, but keep working on notes, homework, and examples.